Welcome to the final chapter of the ALBATROSS Project, a groundbreaking journey in shaping the future of electric mobility for a sustainable future. The ALBATROSS Project set out to tackle the biggest challenges in EV adoption: range anxiety, long charging times, and battery reliability. Our journey unfolded in three major phases. It began with foundational research and development, laying the groundwork for innovation. In the development stage, we engineered advanced battery modules, trays, and a cutting-edge battery management system. Finally, we brought it all together, integrating and testing our custom battery pack in the BMW E3. By combining lightweight materials, advanced thermal management, and next-generation battery systems, we've redefined what's possible in electric vehicle performance, safety, and sustainability. With each milestone, we've moved closer to a future where electric vehicles are lighter, faster, and more efficient, all powered by breakthrough battery technology. Join us as we explore the groundbreaking innovations that are driving this transformation. At the heart of these advancements are the contributions of dedicated experts. Each brought specialized knowledge and groundbreaking innovations that played a crucial role in the success of ALBATROSS. Learn more about the partners behind these breakthroughs in our Consortium series videos.
The most significant achievement of ALBATROSS is the development of a scalable, smart and circular battery system that can be adaptable across all passenger car applications. Thanks to its modular architecture and flexible integration, it can be tailored to different vehicle sizes and requirements, from compact cars to larger EVs.
Let's take a look at the key innovations that made it all happen. The journey began with a complete reimagining of the battery tray, using thermoplastic composites, laser welding, and advanced joining techniques to create structures that are both lightweight and strong.
IMEN Technology Center are involved in the lightweight solutions of battery tray, modifying top cover component of the case from metal to thermoplastic composite material. For this, a completely redesigning of top cover will take place to maintain the properties of final component despite of the material change. No-woven fabric made from recycled carbon fiber and mixed with polyamide 6 fibers from jean to carbon was selected to manufacture ALBATROSS top cover. For ALBATROSS project, due to the final design, two different thickness was manufactured: 1.3 mm and 4.7 mm, 9 and 32 layers respectively. Once we have all the material dry after 24 hours at 60 degrees in an oven, we manufacture the laminates by press process. The adequate parameters were defined previously by a design of experiments in terms of temperature, pressure, and time of maintenance. After that, machining of the internal stringers was made to obtain ALBATROSS top cover design. Finally, assembly of the partitions and the upper and lower plate was made by adhesive or welding process. By reducing the weight of both the battery cover and the casing by 20%, we can significantly improve energy efficiency and boost the vehicle's range.
Next came the development of advanced battery modules, incorporating lightweight aluminum copper components, specialized welding, and printed sensors to enhance both safety and performance.
Here we can see the nickel-plated strips placed on the bench of the cutting machine. We can see how the cutting tool comes down, and it's firstly cutting out all the apertures inside the bus bars so that we can fix the bus bars inside the battery pack. And then finally it cuts out the whole contour of the bus bars and we get out a whole cutted part.
A key pillar of the project was the Battery Management System, BMS, responsible for optimizing performance and safety. Experts developed system architecture, advanced safety algorithms, enhanced cooling mechanisms, and zero-emission heating, while also improving thermal management with printed sensor technology.
Hi, my name is Anna-Sofie Bengtsson from Submission, and I'm standing here next to our catalytic heater developed during the ALBATROSS project. We are now in our cold chamber where we can test the heater down to minus 30 degrees Celsius. It's currently running, as you can hear, and I want to show you a little bit about the heater. The middle part you see here, that's the heat exchanger, and we have the coolant circuit that's heated up by the heater. So we have the coolant inlet here, and next to that we have the fuel inlet with bioethanol, and at the back we have the exhaust pipe. And here you can see the coolant outlet and the air in.
Beyond battery development, ALBATROSS placed a strong focus on sustainability. The project advanced battery recycling methods, robotic dismantling systems, and second life applications aim to extend battery longevity and reduce waste.
Contributed to the ALBATROSS project by focusing on battery degradation, state of health and state of function estimation, and also on the assessment of second life possibilities for the battery pack. Our work aims to maximize the usage of the battery by accurately predicting the end of life and also reusing these batteries in second life stationary applications. To understand battery degradation, we conducted experiments during over 2 years to 6 cells that are identical to the ones used in the ALBATROSS battery pack. When defining testing protocols for batteries, it is quite common to just assume constant operating conditions, for example, constant discharge currents or temperatures. In our case, we wanted to capture more realistic aging and degradation. So what we did was include very different driving cycles in terms of C rates and depths of discharge to accurately mimic what a battery would experience in real-life conditions.
The real test of these innovations came through integration and validation. This included battery pack integration into an electric vehicle, extensive cycling tests to assess battery health, and virtual design exploration for light commercial EV applications, ensuring real-world feasibility. And to measure our impact, a comprehensive life cycle analysis demonstrated a 20% reduction in environmental footprint, reinforcing contributions to the EU's circular economy goals. The impact of ALBATROSS is undeniable. A 20% reduction in battery weight for greater efficiency, charging times cut by 25%, extended battery life to 300,000 kilometers, and significant improvements in environmental performance.
I think every solution that was discussed today about battery optimization could have a positive impact on the future. Especially as someone who works in software, it's super interesting to hear and learn more about what goes on in the other departments of the EV driving world. And I think it's very good what you do in June. I don't think people understand how important this can be and how much of a positive change it can bring for electric vehicle drivers in general. So I really hope the media gets more coverage and your project goes on even further than this.
Thank you.
I wanted to study about the thermal management of the battery. So that part of the battery which was actually interesting for me, how he explained about the partial immersion cooling and the full cooling, how it affected the battery. So I wanted to learn about all those things, how they are actually changing all those batteries. And once you have connection with the spot welding kind of a welding, I thought he said about the laser welding. So that laser welding, what is the resistance after that, and what is the problem after we are facing, and how much deep it is going to the bus bar. So that part of the things which actually interested me for more. And the crazy part was when we are actually welding the laser, how it is affecting the whole battery performance, what exactly is heating up the battery. And so those 2-3 points actually caught my attention on that one. So I think the thermal management of the battery actually was interesting for me.
Yeah, I think from what I could read and assess a little bit in the short term from Albatross, you guys focused quite deep in the thermal management of the batteries and all the ecosystem around it. So I think that's a key element for the degradation of batteries and how they evolve over their life cycle. So I think that's for sure will bring good outcomes to improve the aspect of the degradation of batteries.
I think, especially looking at the modules, it was a lot of looking at the drawings, maybe trying some subscale modules, some subscale welding, and then we went to the full-scale welding, and it had to be right immediately. And I think that was that we made it work relatively well if you look at it that way.
Both the cooling, the projects about cooling. I mean, it's a very efficient way to keep the cells at optimum temperature, and also the very quick heating technologies.
These advancements mark a major step forward for electric mobility, making electric vehicles lighter, faster, and more sustainable. Albatross is more than just a research project. It's a step towards a cleaner, smarter, and more sustainable future for electric mobility. Join us on this journey.
Let's say PST part was actually on the thermal management of batteries. What is important for the performance of the battery first, and more important for the safety of the battery. And we're doing with our technology what is based on printed sensors. They are conformable and fit to every form factor inside a battery. Measuring temperature on more or less every cell, do a 3D reconstruction of the temperature, and use this information to communicate to the battery management system. But the important feature is that not all the big data going to the battery management is actually worked out before. And the aim is that the battery can be run at the proper temperature adapted to the load of the battery. Normally you have a temperature range where it has to run, but for certain load structures, it's better to adapt every cell to the right approach. So you make it better, that's the first thing. And when you have the full overview what your individual cells are doing, then it's on the safe side.
Immersion cooling has been selected as the best method based on the criteria within the ALBATROSS project. Criteria of weight reduction, costs in vehicle packaging, readiness of the technology. In particular, the partial immersion cooling is an innovative solution that we found in Nottingham to achieve the key performance from a thermal point of view of the battery pack, so maintaining the optimum range of temperatures of the battery pack with the advantage of weight reduction of the whole system. We specifically designed the system, the cooling design in particular, to achieve a temperature difference between the different cells less than 3 degrees Celsius. And partial immersion cooling has proven to be an effective solution in this regard. So that's why we came up with this solution.
Yeah, I think in NTNU we offer several innovations to the recycling process we want to develop. First is closed loop, and the second is robust or compact process. Closed loop means that we have to consider energy or chemical or any material we put into our process that we should have a chance to get it back in the end of the process. The compact process means we have proposed less stages, less complicated process, which means we have came with ideas with less input material and less energy. So we think that combination of the closed loop and the compact process, like I mentioned before, which means that we can maximize the recovery and also minimize the waste, which means less environmental impact.
We require an appropriate methodology to evaluate the environmental impact for batteries. That's why we are considering the impact wall plus methodology, which can translate all of the input-output data into the appropriate environmental metrics such as carbon footprint.
Visit our website to explore the full results and check out our previous videos to dive deeper into each innovation. This project is funded by the European Union